Welcome, good morning, good afternoon, good night, whenever time it is you're watching this video. Okay, today we're talking about dot products. Okay, the dot product is handy because it's going to help us find angles in between two vectors. Okay, so the dot product. So here is the definition of the dot product. Okay, what we do is if you have two vectors and you are quote unquote dotting them, like multiplication, you multiply the x component of your vectors together, and you multiply the y component of your vectors together, and then you add those two products together. So a dot product is multiplying your like components and then adding those products together. Okay, multiplying twice, adding once. And here are some properties of the dot product. So it's commutative, right? U dot V is the same as V dot U. There's distributive, so you distribute the dot product, bless you, into both of your parentheses. Okay, this is a multiplier, so you can either dot first or you can multiply by the U and then dot it, so you can multiply different things, right? It's a scalar multiplier. 0 dot V, of course, 0, right? A 0 vector times another vector is 0. And then if you multiply a vector by itself, that's the magnitude of your vector squared. Okay, so these are some properties that we're going to encounter as we work through some problems involving dot product. So here we have three vectors. We have a u vector, we have a v vector, and we have a double v vector. Just kidding, w. So here's your u vector, here's your v vector, and there's your w vector. Okay, so we're going to use those vectors to practice this dot product stuff. So u dot v. So we have -1, 3, that's our u vector. Dot 2, -4, that's your v vector. Okay, so the procedure says we do the x components times each other. -1 times +2 is -2 plus the y components multiplied together. 3 times -4 is -12. So -2 plus -12 is -14. And that is the dot product. Notice there's no more vectors, right? A vector dot a vector is not another vector. It is a scalar, or it's a multiplier, right? A scalar is a multiplier quantity. So -14 would be the dot product of u dot v. So let's do our next one, u dot 2v. So we have that u vector again, -1, 3. Dot, let's multiply v by 2. So we're going to double each of those components. So 4 and -8. Okay, so we are multiplying our v vector by 2. And now we're going to perform the dot product. -1 times 4 is -4 plus 3 times -8 is -24. So then -4 plus -24 is -28. Okay, these are a dot product. The answer is a number. And our third example looks like it is using property number 5 from up above, right? So here's property number 5. Nope, that's not it. We're using property number 3, the distributive property. So we're going to distribute this into both of our vectors. So v dot w plus v dot u. Okay, that's basically the distributive property of the dot product. So our v vector was 2 minus 4. Our w vector is 1, -2. Plus my v vector again, which is 2 minus 4. dot my u vector, which is -1, 3. And we do our dot products. 2 times 1 is 2, plus 4 times, or -4 times -2 is +8, plus 2 times -1 is -2, plus -4 times +3 is -12. So we're looking at 10 plus -14 is a grand total of -4. Okay, so these are dot products, right? This is how we calculate a scalar value called the dot product. You multiply the x component together, you multiply the y components together, and then you add those two products together. Okay, dot product, vector multiplication. And we're going to use the dot product to find the angle between two vectors. So notice here are the parts of how you find the angle between two vectors. The dot product is in the numerator, right? This is the dot product that we were just talking about. And both of these down here, these stand for the magnitude. So this is a product of the magnitude of each individual vector. So there's 3 calculations that we have to do. We have to do the dot product of your two vectors. We have to find the magnitude of the u and the magnitude of the v. So we're going to perform 3 operations before we get to find out what our angle is. Okay, so let's get to doing that. Here are your 2 angles, 4, 3, and -2, 5. So first, let's do the dot product. U dot v. Okay, 4, 3 dots -2, 5. So 4 times -2 is -8, plus 3 times 5 is 15. -8 plus 15 is 7. So these two vectors have a dot product of 7. Okay, now let's find our 2 magnitudes. So the magnitude is always found by the Pythagorean theorem, the square root of 4 squared plus 3 squared, right? So it's your x term and your y term. Square root of x squared plus y squared is, let's see, 16 plus 9. 16 plus 9 is 25. The square root of 25 is 5. Excellent. And now we do the same thing for our v vector. We find its magnitude. So remember, this double bar is the symbol for magnitude. So our x part is -2. Our y part is 5. -2 squared is +4, plus 25 is root 29. Okay, and we're just going to leave it as root 29. We don't have to decimal approximate it right now at all. Now let's go to our formula. So I'm going to solve this for theta, which means I take the inverse cosine of both sides. Okay, so my answer is theta equals inverse cosine of. Okay, on top goes my dot product. U dot v was 7. The dot product of these two vectors is 7. And in the denominator, the magnitude of our u vector, which was 5, times the magnitude of v, which is root 29. Okay, so now all we need to do is plug this into our calculator. Okay, if you're using an Nspire, you can hit the Control Divide button in order to make a fraction. But make sure you're in the degree mode so that we get a degree answer. And there's your answer rounded to 1 decimal. Okay, so let's take a second and talk about what that looks like geometrically, aka on a graph. So we have our u vector, which is 4, 3, so 4 right and 3 up. So here's your u vector. And then we have our v, which is 2 left and 5 up. All right, so these are our two vectors that we are finding the angle between. So when we find our theta, we're finding this, the angle between these two vectors. Right, and I can believe that's about 75 degrees. So my answer makes sense based upon my picture, right, which is just a rough sketch. It's not an awesome thing, but it's good enough for me to know that what I'm doing looks like it's right. Okay, so now we have our application problem, right? This is one of the physics application problems that we do with vectors. Very frequently, they are vector or physics-based applications. So forces of 20 newtons and 30 newtons have a resultant force, right? The resultant is the answer that comes from the sum of these two vectors, is 41.357. What is the angle between the 20 and the 30? Right, so that's what we're trying to find. So let's do a drawing of this real fast. Let's put some axes on here. There's your y-axis and your x-axis. So from our last video, we know to put the first vector, so the 20 Newton vector, it's listed first in our problem. We're going to draw it first. We start at the origin, and you're going to draw a line going directly to the right. And you're going to label that 20 newtons. Okay, so that's our 20 Newton vector. Now, if the result was 50, then they would be going in the exact same direction. Okay, if two forces are pulling in the exact same direction, then you simply add their two forces together, and that gives you the total. Well, because our total is less than 50, we know that there's going to be some angle in between these two vectors. So I'm going to draw my 30 Newton vector at some random angle. I have no idea what that angle is, so I just draw it at some angle. And this is what we're going to be calculating, the angle in between these two vectors of 20 and 30. Now, in order to find our resultant, because we have to put that in our picture too, we make a parallelogram. The resultant is the diagonal of the parallelogram created by your two force vectors. Right, so we have the top vector, right, which would be the 20 of the parallelogram, and the 30 over here, right, because a parallelogram have opposite sides that are equal and have the same slope. So the resultant is the vector that goes from the origin along the diagonal of our parallelogram. This is your resultant, 41.357. Okay, so here's the picture. Right, we have a 20 Newton force going to the right, and we have a 30 Newton force acting at some angle that we don't know, resulting in a 41.357 Newton force. Okay, so what we're going to do is we're going to look strictly at this triangle right here. Okay, because with a triangle, I can use some other trigonometry, right? Something that we learned earlier in the year is called the law of cosines. The law of cosines is the formula that we use anytime we know three sides of our triangle, right? It is applicable for side, side, side. And if we know three sides of our triangle, we can find the angle across from any one of the sides. So we could figure out what this angle down here is, right? This is this angle of our triangle. If we have 30, we could find this angle up here, which is across from our 20, or we could find this purple angle, which is across from your 41.357. Now, for our parallelogram, which angle makes the most sense to calculate? The purple angle here. This belongs to our triangle, right? It is the obtuse angle of your triangle. and it's also one of your consecutive angles of your parallelogram. Okay? So I know that's from geometry, and you might not remember anything from geometry, but these are your consecutive interior angles, and they add up to 180. So if I can calculate this purple angle here, that means I can subtract it from 180 to calculate the angle that I actually want. Okay, so we're going to call this angle alpha. So we need to know that alpha plus theta, our angle that we want, add up to 180. That is a geometric property of all parallelograms, that their consecutive interior angles add up to 180. Okay? We want theta. Theta is our answer, but we cannot find it directly. We have to first calculate alpha, this angle right here. So that's what we're going to do using the law of cosines. Okay? So this is how we do that. We say alpha equals the inverse cosine. So I am solving my law of cosines for my angle. Okay, let me write down the law of cosines real quick. So there's the law of cosines. Notice the side that we're trying to find is always associated with the angle that we are using. So I have this equation, my alpha equals, that's solving my equation for A. Okay, so what we do in relation to our problem is you take your, so B and C are your vectors 20 and 30. Okay, so we're going to call B the 20 vector, 20 squared, plus your other vector, which is 30 squared, minus, right, there's a minus in our problem, so there's a minus up here, minus your resultant, minus the resultant squared. And this is how we're always going to do it. We're always finding the angle across from your resultant. So we're always going to put in our problem like this. Vector 1 squared plus vector 2 squared minus the resultant squared. Right? That's this part of our law of cosines. Now, on the bottom, we're going to do 2 times 30 times, sorry, that's 20. 2 times 20, I did 20 in red, times 30. So this is the formula that we're going to use to calculate our angle using the law of cosines. Okay, so 20 and 30 are your 2 vectors. And then 41.357 is your resultant. The resultant is across from the angle that we are calculating. That's why we have written it like this. 20 squared plus 30 squared minus the resultant squared. Okay, put this all into your calculator, all at once. Go ahead, I will wait.
I got undefined.
Put it in your calculator. So your calculator says 109.99999. So we're going to round up to 110. Okay, basically this only has 3 decimal accuracy because it would take a lot of space. So remember, that's this angle, 110. That is not our answer. Our answer is 180 minus that thing that we've calculated. Okay, 180 minus 110 is 70. So the angle in between our 2 vectors to begin with, in between your 20 and your 30 is 70 degrees. This angle right here is 70. Okay, so we don't solve it directly using the law of cosines. We solve for the angle across from the resultants. But because this is a parallelogram, these 2 consecutive angles add up to 180. So we subtract what we've done from 180. Okay, that's probably the hardest problem that you're going to do, to find an angle. Okay, good luck, good brains, have a good time, goodbye.